Hello my dear students, this is Akash SD. Welcome to the ASD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the graphs and the types of graph, okay? And whatever basics you will learn in this video, that will be very useful in 12th also, okay? So let's start the video. So here you can see under the graphs, what is the graph? See here. It is the graphical representation of one physical quantity with respect to another physical quantity. That means here the two physical quantities will be involved, okay? And what kind of physical quantities will be available in this video now? Based upon the 11th, you can see very well the physical quantities may be position, maybe velocity, maybe acceleration, and maybe time. In 11th, in 12th you will see maybe electric field, maybe electric potential, maybe EMF, okay? So this video we are just going to focus on the 11th, but basics are important in 12th, is it? As I have told you, okay? So now if you talk about the types of graph here. So first graph you can see very well, the position time graph, we can tell even XT graph also, okay? Second one, velocity time graph, even we can tell VT graph also, okay? Third one, acceleration time graph, even we can tell AT graph also, okay? And here on the horizontal axis, I will take time, and on the vertical axis, I may take position, maybe velocity, maybe acceleration, okay? So these three graphs are the main graph. Now, these three graphs are the main graph. After that, multiple types of graph is possible, like you can see very well, velocity position graph, or you can tell acceleration position graph, and other graphs also, okay? So by taking any two physical quantities, we can draw the graph here, is it? So this is the basic of the graph. Now what we are going to do, we are going to learn one by one these graphs here, is it? So let's see here. So now you can see very well, students, the first one we are going to learn the position time graph important points, is it? So let's first learn the important points, then we'll see the cases of the position time graph also, okay? So let's see here. What is the first point? That means point number A. See here. The slope of tangent drawn to the XT graph at any instant of time gives the instantaneous velocity at that instant, okay? If I talk about here even the mathematically, so we can write here V equal to dx by dt. And what is the significance of differentiation? Slope, is it? So we can write here V means V equal to slope of XT graph here. Is it? Differentiation. Differentiation. Significance, the slope here. Is it? Here, the slope. And slope, I hope so you know very well, the slope is represented by M, or we can write here M equal to tan theta here. Is it? M equal to tan theta. Now, and what are the things are there? Remember that here. When, for example, when theta is 0 to 90 degree, okay? In this situation, what will happen that here? This slope M will be positive. What will be there? The slope M will be positive, okay? Similarly, if we talk about here theta equal to 90 degree, and you know very well tan 90 is not defined. So for 90 degree, the slope is not defined. M not defined. M not defined. Is it? Similarly, if I write here this one here, let's take here theta greater than 90 degree and less than 180 degree here, okay? Less than or equal to 180 degree. So in this situation, what will happen that here? This slope M will be negative, which is applicable in all the situations. So 0 to 90, slope is positive. 90 degree, slope is not defined. And when 90 to 180 degree, that means obtuse angle, the slope will be negative, is it? Remember that here, these basics. After that, if we talk about here the next ones here, see, slope of XT graph can never be infinite, as I have told you very well, no? Because M infinite, theta 90 degree not defined here, okay? So slope of XT graph can never be infinite at any point, because infinite slope represents uniform velocity. That is not possible practically here, okay? That we are going to see that how it will come. And next one, third one, say here, at one time, two values of displacement is not possible. Even practically also we can think time is one. Now at any specific time, how two values of displacement is possible? Not possible here, okay? So if we talk about here, let's take here, if I talk about here this position time graph. So remember that here, if in case the graph is given like this, so I'm talking about for the point number C previous. Now let's take given like this here, is it? And let's take after that it went like this here, is it? So here what is happening that here you can see very well. Here the slope is what? The slope is here. This line you can see here now, this vertical line you can see here, is it? So here what is happening that here in this situation the angle is 90 degree, na? Because whenever we have to make here the angle, see here, this 90 degree, is it? So slope 90 degree is not possible. That means anyhow this graph is not possible. The line cannot be vertical. Vertical line is not possible. This graph is not possible, is it? Wrong graph. Similarly, if we talk about for the point number D, as we have seen that, so there what they are telling that here at one value of time, two displacements or position is not possible. Remember that here, like x in the question they may use for the distance term, they may use displacement term, they may use, and they may use the position term also. Okay, so interchangeably they used to use these three terms, maybe position, maybe distance, maybe displacement here. Okay, so like if we talk about here, let's take the graph is given like this here, is it? So in this situation you can see very well. Now in this situation what we can see here, if you draw here one line like this here, is it? So you can see here very well. Let's take that time is t naught, but at this time t naught, how many possible values of the position is coming? Here one value and here one value. Okay, so at any specific time, how the two possible positions are there? That is not possible, is it? So this is also wrong. Okay, so remember that here both these situations, and this one telling point C and this one is telling point D. Here I'm telling you here, see this is see here, oh okay, this is point B and this is point C, is it? I will just correct it here now. So what is happening here, see here, this is point B, this is talking about point B, okay, and this one is talking about a point C here. Now this one is talking about a point C here, is it? Now I hope so this is very clear to you. Now students, after that what we are going to see, we are going to see the cases. So see here, position time graph cases, and first one we are going to see case 1. So here what is happening that here, let's take here on the horizontal axis time, unit is second, on the vertical axis position, and SI unit is the meter. So if in case any time the graph is the horizontal line, horizontal line here, and let's take for example here, this is for example x naught here. Remember that here we are using x t graph, position time graph. Even if the object is moving along y direction, we can write yt. If the object moving along z direction, we can write zt. Okay, but by default we are taking xt here, by default here. Okay, so here what is happening that here you can see very well when the time is passing. Now what we can tell here, let's take for example, see here, for example let's take here, if the time is 1 second, position x naught. If the time is 2 second, position x naught. When the time is 3 second, position x naught. So you can see with the time, position of the object is changing. That is not at all changing. That means what we can tell here, the first thing we can tell here, object is at rest. What is happening? The object is at rest. Which kind of rest? Which kind of rest? Remember that here, the object is at rest and permanent rest here. Two kinds of rest is possible, permanent rest, instantaneous rest. Okay, but here the position is not at all changing with time. That means permanent rest is there. Okay, so when the object is at permanent rest, anyhow its velocity how much here? Permanent rest velocity we can write here, velocity will be 0, is it? And even if we talk about here the acceleration also, acceleration, okay, permanent rest anyhow. So here also acceleration also how much here? 0. So remember that here horizontal line represents what? This represents object at permanent rest here. Okay, so this is the case 1. Okay, great. Now students, after that when we'll go for the next one here, what you can see here, here you can see with time what is happening, the position is keep on changing here. Okay, and here if I talk about here, let's take for example, if I talk about here like this here, see, let's take like this here, and let's take, I have taken the time 1 2 3 and let's take here positions, like this positions are there, and let's take for example 2 4 6, is it? So remember that here whenever inclined straight line is there, this represents uniform velocity. Uniform velocity means equal change of position in equal interval of time, is it? You can see very well, first second moved 2 meter, 0 to 2. Next second, that means 1 to 2 moved 2 meter, 2 to 4. Similarly, next second 2 to 3 moved 2 meter, 4 to 6. Is it? That means equal change of position in equal interval of time here. Okay, so here remember that here in this situation, what we can tell, object is moving with a uniform velocity. Na? Write down here, see, object is moving with a uniform velocity. Na? Can you remember that here? Object is moving with a uniform velocity. Object is moving with a uniform velocity. Okay, now uniform velocity. Now acceleration how much here? You know very well. When the velocity is uniform, acceleration any how much here? 0 here. Okay, so even if I write here the acceleration will be 0 here. Okay, acceleration 0. And one more thing here, object is moving away from origin or towards origin. Remember that here with the time axis keep on increasing. That means remember that here object is moving away from origin. Okay, I'm writing here, see, object is moving where? Away from origin. Is it? Object is moving away from origin. Why I left this start? Because I am going to calculate the velocity value, this uniform velocity value. So remember that here whenever the straight line, we can directly calculate the velocity. Na? You can see when if I talk about here, this angle is for example, okay, alpha, na? Or even you can write theta also, no problem. So we can write here even v equal to tan alpha, na? Acute angle, so anyhow velocity will be positive, is it? But here if we want to calculate the velocity, how can we get the velocity here? I can take here any 2 points. Let's take it here. I have taken the points here. The coordinates how much here? You can see very well, 2, 4. Now what is the coordinates here? Coordinates are here, students, say 2, 4. Now I'll try to write somewhat bigger, 2, 4. Okay, and here what is the coordinates? You can write here 3, 6. Is it? So if I write here, I can write here, remember that here, students, like this here, see, x3 minus x2 by 3 minus 2. That means position at t equal to 3 minus position at t equal to 2 by 3 minus 2. This is the way to calculate the average velocity. Okay, so what it will come here? X3 how much here? At t equal to 3, x value 6 minus at t equal to 2, x value 4. So 6 minus 4 by 3 minus 2. What is coming here? You can see very well. 6 minus 4 means 2, 3 minus 2 means 1. So 2 by 1 means 2 meter per second. Is it? Remember that here. That means the object is moving with a uniform velocity of how much here? 2 meter per second away from the origin. Uniform velocity, acceleration how much here? 0. Is it? I hope so. All these basics you are understanding very well. Is it? Now students, after that if we will go for the case 3. So in case 3 what is happening that here? Let's take for example, just let me write here. Okay, so see, can you see object is moving away from origin or towards origin? Anyhow you can see with the time the x values keep on decreasing. That means object is moving towards origin. See, away from origin it is coming positive, +2. So towards the origin it will come -2 because velocity is a which quantity? Vector quantity. Okay, so see here if I write here, see, 0, 1, 2, 3 for example, and here I am writing here, see, 2, 4, 6. Is it? So if I write here, can you see? First point, as it is, object is moving with a uniform velocity here, no? Because inclined straight line, object is moving with a uniform velocity. Okay, object is moving with a uniform velocity. Is it? Object is moving with a uniform velocity. Where? Even here itself I can write here, towards origin. Okay, towards origin. Okay, now after that here, if I calculate the velocity, remember that here, this slope always, we always to take here the anti-clockwise. Now, so let's take here, this angle is beta. Which angle? Obtuse angle. That means velocity will be anyhow negative. Okay, because moving towards origin. But if I take here the some points like before, let's take here, I have taken 1 point. Let's take here the coordinates how much here? See here, 1, 4. Is it? And here how much here? You can see very well, 2, 2. Is it? Any 2 points you can take here. No? So if I write here the velocity, let's take here, I have taken which points? 2 and 1. Any 2 points you can take. So I can write here, see, x2 minus x1 by 2 minus 1 here. Is it? So what we can write here, what is the value of the x2? x2 means 2, x1 means 4. Is it? So we can write here, see, 2 minus 4 by 2 minus 1. What is coming here? It is coming here minus 2 meter per second. That's why minus is coming. Away from the origin, positive, plus, plus. Towards the origin, negative. Okay. And anyhow here, students, which kind of velocity is there? You know very well, uniform velocity. That means acceleration, how much here? Acceleration will be 0 here. Is it? Remember that. No? So see, in how much beautiful way we have seen this case 2 and case 3. Okay, great. Now students, after that, if we will go for the next one, see here, if this kind of graph is given like x versus t graph is somewhat a parabola in nature, like this here. Okay, so remember that here in this situation, what will happen that here, if I take here, let's take for example some specific times. Okay, so see here like this. So here what will happen that here, in equal interval of time, object will travel different distances, different positions here. Okay, just for the example I'm writing here. Now just for the example I'm writing here. Just for the example, let's take for example 1, 2, 3. Is it? So here what will happen that here, let's take for example here 1, let's take here, let's take 4 here, let's take for example 9, like this. Okay, so here you can see very well. First second 1 meter, next second 1 to 4, that means 3 meter, next second 2 to 3, that means 4 to 9, that means 5 meter. That means what is happening, in equal interval of time, object is traveling unequal distances. Is it? So here what is happening that here, we can tell very well, what we can tell, object is moving with a, remember that here students, object is moving with which velocity? Non-uniform velocity. Okay, see I'm writing here. Object is moving with non-uniform velocity, and anyhow with the time x is increasing away from origin. Okay, away from origin. Is it? Now after that, velocity will be positive or negative. Anyhow the object is moving away from origin, velocity will be what here? Velocity will be positive. For that you have to do here v equal to dx by dt. Okay, v equal to dx by dt, that means you have to see here the slope of xt graph. What you have to see here, the students, you have to see here the slope of xt graph here. Is it? So if in case I just write here the slope. Okay, so just let me see here. I'll just try to do here. Let's take for example here, I have drawn here the slope with this red color, like this. No, this is the one. After that, if I talk about here, let's take at this point here, like this. No, so if I talk about here the angles, let's take for example, this angle is, let's take for example theta 1, and this angle is theta 2 here. Now we have just drawn here the tangents at this point here. Okay, so what is happening that here, with the time the angle is increasing, you can see very well the theta 2 is greater than theta 1. That means anyhow what is happening, the velocity of the object is increasing. Velocity of the object, what is happening here, students, increasing. Remember that here. Okay, little bit complex topics, remember that here. And if we talk about here the acceleration, okay, acceleration, it is given by a equal to dv by dt. Okay, so when we'll get the expression of the velocity after differentiating x, then when I and we will differentiate, we will get the acceleration here. Okay, so acceleration, most of the time it used to be the what we can tell here, the acceleration used to be the uniform acceleration, but depending upon the types of graph here. Okay, so I hope so this one is the very clear to you. Again I'm telling that here what is happening here, the velocity is increasing, but one more thing is there, definitely this acceleration will come positive. What will happen, the acceleration will come positive, and here also when you will solve, the velocity will also come positive. So anyhow we can tell v is positive, a is positive, anyhow velocity have to increase. This is a very basic. Okay, great. Now students, after that if we will talk about here this graph here, is it? So in case of this graph, what will happen that here, if I take some points, let's take here I have taken one point, and if I draw here the slope, see like this here, like this slope will be there. Okay, similarly if I talk about here one more point, let's take, I have taken some point here. No, okay, I'll just try to do here like this, it is going here. Okay, so what is happening that here, students, just let me take your back side somewhat. Is it? So here what will happen that here, students, let's take for example, if this angle is theta 1 and this angle is theta 2. So here what has happened that here it has happened that theta 2 is greater than theta 1. Okay, but here what will happen that here, students, here what will happen that here, this theta 2 is less than theta 1. No? Here theta 2 is greater than theta 1, but here theta 2 is less than theta 1. Here at this point we have got the slope, and at this point we have got the slope. Even you can write the point names also. Let's take point A, B, and here also I can write here point A, point B. Is it? So here what will happen that here, students, as the slope is decreasing, the velocity will decrease. What will happen? The velocity will decrease. Okay, and again what we can write here, object is moving with see here, object is moving with which velocity, students? Non-uniform velocity. Okay, because velocity is changing, object is moving with a non-uniform velocity, and where? Towards the origin. No? Towards the origin. No? Towards the origin. If I talk about here the velocity will be given here anyhow, dx by dt. And when you will do here what will happen that here, you can see very well in this situation, students, like here the slope was keep on increasing, velocity was increasing. Here what is happening that here, students, velocity is decreasing. So when you will do here anyhow, the angles are acute kind of angles are there. So what will happen that here, velocity will come positive only, but it will keep on decrease. Like if we talk about this case, like 1, 2, 3, 4, here what will happen that here, decreasing, for example 4, 3, 2, 1, just for the example. Okay, but if we talk about here the acceleration means what will come here, dv by dt. Okay, so here what will happen that here, remember that here in this situation, students, what will happen that here, acceleration will be negative. Okay, so I hope so you know very well, when the both are positive, velocity will increase, but when one positive and one negative, anyhow what will happen that the velocity will decrease. Okay, remember that here. So I hope so this the slope concept is very clear to you, is it? Now students, after that, after completing the position time graph, we are going to move for the velocity time graph here. Okay, so let's go through it. Very important graph, velocity time graph, very important. Okay, so see here, see the first point, the slope of tangent drawn to the VT graph at any instant of time gives the instantaneous acceleration at that instant. How can we tell here? See here, A equal to dv by dt. Okay, or what we can write here, this is the slope of VT graph. Now the slope of VT graph will give us what? It will give us acceleration. And as I have told you very well, the slope means acute angle, always angle anti-clockwise, acute angle slope positive, 90 degree slope undefined, obtuse angle, that means 90 to 180 degree slope will be negative. Is it that basic? I have told you, is it? Now see here the next point here. What is your next point here? Area under VT graph gives, first one, distance if area above and below the time axis is positive. Okay, and second one, even we can get the displacement also if area above the time axis is positive and below the time axis is negative. Okay, so what I am going to tell you, see, remember that here, as we know, A equal to dv by dt. Na? In the same way, if I write here, see here, you know very well, see, v equal to dx by dt. Is it? This also you know very well. So what can we write here? See, this dx equal to v dt here. Now integration. Is it? So integration, that means the area under the VT graph will give us distance and displacement. How many possibilities are there? 2 possibilities are there. Is it? 2 possibilities are there. So what I have told you very well, remember that here. Let's take, for example, if I talk about here, let's take this area and this area. 2 areas are there, na? And let's take, for example, I have taken this area A1 and this area how much here? A2. Is it? So what will happen that here, when we have to calculate here the distance means what will happen that here, just calculate the pure area with the magnitude here. Now here no need to take like V is negative, you are taking A2 negative, no, just pure magnitude. Okay, so distance means what will happen that here, just add both the areas. After calculating the area, pure magnitude, add both the area, you will get the distance. Similarly, if I talk about here the displacement. So what will happen that here, upward area positive, downward area negative. Is it? So this basic you should remember that here for the velocity time graph here. Okay, great. Now students, next one, as I have told you before also, now for the position time graph, same applicable here also. What is this? See, slope of VT graph can never be infinite at any point, because infinite slope represents infinite acceleration. That is not possible practically. Same basics I have told before also, na? Get the reference from there. Next one, see, at one time, two values of velocity is not possible, as I have told you, is it? So now students, next one we are going to see the cases of which one? The velocity time graph, very, very important. Okay, the basics will be same, but here you have to analyze the graph and then we have to write the important points. Maybe here onwards some confusion may come between position time graph and velocity time graph. So you have to understand very well, you have to see multiple times, so only the confusion should not come. Okay, great. So now here students, velocity time graph case 1. So here what is happening, that here, see here, I have taken velocity v0. So you can see very well, if I take same basics, if I take the time 1, velocity v0, if I take even time 2 second, velocity v0, even if I take time 3 second, how much here? Velocity v0. So velocity of the object is changing, not changing. So remember that here, what is happening? Here I will talk about here velocity time graph. So we can write here, see, object is moving with a uniform velocity. What is happening? The object is moving with a uniform velocity. How much here? Here the uniform velocity is v0. Okay. Now after, let's see here, as the velocity is uniform, acceleration will come how much here? Acceleration will come here 0. Okay, acceleration will come here 0. No? And velocity is positive, so you can tell, no? Velocity is positive, so velocity positive means you can see here, no? Velocity is coming greater than 0, so we can tell, okay, moving away from origin. And if in case the graph is negative, let's take for example, then we can tell towards the origin, depending upon the question situation. Okay, so see here, the velocity time graph case 1. Okay, great. Now students, let's move for the second case here. No? So here what is happening, that here, see here students, again also I will write here, no? Here velocity time graph is there, same basic I will use here. Let's take here 1, okay, let's take here 2, basic is same here, okay, let's take 3 here, and here I have taken here, no? Let's take here like this here, no? So what we can tell here, see, let's take 2, 4, 6. Here what is happening? Equal change of velocity in equal interval of time. In this 1 second, velocity change 2 meter per second. Next 1 second, velocity change 2 meter per second. Next 1 second, velocity change 2 meter per second. That means the object is moving with a uniform acceleration. Okay. So first let me write here the first pointer, velocity is changing. So we can write here object is moving with a non-uniform velocity. Now because velocity is changing. Okay. So object is moving with a non-uniform velocity. Second point, if I talk about here, acceleration. Acceleration means same story. We can write here, if we talk about here, let's take for example even angle. So we can write here, let's take here angle alpha. No? Because slope of VT graph gives the acceleration here. Is it? And here what we can write here, again, you can take any 2 points. Let's take here, this is point A and this is point B. Here coordinates 2, 4 and here coordinates 3, 6. Is it? So what we can write here for the average, which points we have taken? At time 3 and at time 2. So V3 minus V2 by 3 minus 2. Is it? So what we can write here? Kindly see here. V3 means at t equal to 3. 6 at t equal to 2, 4. So in the same story, see here. 6 minus 4 by 3 minus 2. What is coming here? See. Plus 2 meter per second square, constant value. That means which acceleration here, students? This is which acceleration here? This is the uniform acceleration. Remember that here. Uniform acceleration here. Okay, uniform acceleration. Other things and all, I think so. This is a very, very clear to you. Is it? Similarly, you can see very well, velocity is a non-uniform, but acceleration is a uniform. Remember that here. Okay, and one more thing, you can see very well here, students, here the velocity is greater than 0. Acceleration also is coming greater than 0. That means here what is happening, that here the velocity is increasing. This is the basic. Okay, this is the basic. Now students, next one if we talk about here also, let me see here. Let me just see here. Okay, so here also I have taken this kind of situation. Let's take 0, 1, 2, 3 time, and here let's take 2, 4, 6. Same basics what we have done before. So what is happening that here, students? Kindly see here also the velocity is positive here, but velocity positive but changing. Here also what is happening? Velocity is positive, changing and decreasing. Here increasing, but here decreasing. Okay. So here also what we can write here, students? Remember that here object is moving with a non-uniform velocity. Okay, non-uniform velocity, non-uniform velocity. Okay, and next one, if we talk about here the acceleration, now, so see here again I have taken some points. Let's take this is point A and I have taken point B, and this angle I can write here beta, even if sometimes in the question angle they have given. So just by using this tan beta also you can get the answer. Otherwise we need the coordinates here. Here coordinates for B coordinates how much here? See here 2, 2. Here coordinates how much here? 1, 4. Which points I have taken here? Remember that here this is B and this is beta. This is beta. Okay. So see here I have taken the time t equal to 1 and t equal to 2. Okay. So we can write here, see, any 2 points you can take V2 minus V1 by 2 minus 1. Is it? So see here at t equal to 2 how much is given? 2. At t equal to 1 how much velocity? 4. So see 2 minus 4 by 2 minus 1. What is coming here? Minus 2 meter per second square. How much here? Minus 2 meter per second. That means here we can tell acceleration is negative, velocity anyhow positive. Remember that here. See here the velocity in this quadrant, first quadrant I'm talking about here. First quadrant. V is greater than 0 decreasing, but anyhow positive only. V greater than 0. A negative less than 0. So what will happen that here? Here velocity will decrease. Remember that here. In this quadrant I am talking about. If in case the graph is shifting downwards, so there what will happen that velocity will become negative, acceleration will become negative, and that time velocity will increase. Okay, remember that here. Now here what will happen that here we can tell that here uniform retardation. Now because acceleration is coming negative now, so whenever for example velocity positive, acceleration negative, so velocity will increase, velocity will decrease, we can tell uniform retardation. Reverse case also there. Let's take for example velocity negative but acceleration positive. In that situation also what will happen? Velocity will decrease and we will use the term uniform retardation. Is it, students? So can you see very well this situations also velocity time graph here. Okay, great. Now students here also you can see here what is happening that here. Remember that here the first thing now. Here if we talk about here what is happening that the velocity changing. So we can write here, see, object is moving with which velocity? Non-uniform velocity. Okay, non-uniform velocity. Remember that now because velocity is changing. And what about the acceleration? Before acceleration was uniform, but here acceleration will be non-uniform. Okay, how to get the acceleration? Remember that here A equal to dv by dt here. Okay, and here what is happening that here again I am telling you we have to take the slope now. So if I talk about here point A, just take here, this is the slope like this, like this here. Similarly if we talk about here, let's take for example here point B now. So you can see you have to draw the tangent like this here. Okay, and let's take for example this angle theta 1, this angle is theta 2. So what is happening that here theta 2 is greater than theta 1. That means acceleration is dv by dt, and what is happening that here in this situation acceleration is increasing with the time now because slope is keep on increasing. So what is happening that here acceleration is increasing, acceleration is increasing with the time here. Okay, acceleration is increasing with the time. Okay, great. And which kind of acceleration is there, students? Remember that here non-uniform acceleration. Which acceleration here, students? Non-uniform acceleration here now because it is depending upon the time when you will do the differentiation and all that now. Anyhow it will be depending upon the time. It will be depending upon the time. Okay, remember that. Similarly if we talk about here students here, let's take for example here also if I take here the slope now. If I take here the slope here, let's take here see try to draw here the straight line here as much possible. Now similarly if we talk about here, so see here I'm trying to do it actually now, and before also I have told this here now. So see here, and if I talk about the angles, let's take here this angle anyhow theta 1, this angle anyhow theta 2, always angle anti-clockwise wise. So here what is happening that here, see that theta 2 is less than theta 1. So here what was happening, the value of the acceleration was keep on increasing, but here the value of the acceleration is keep on decreasing because slope is decreasing. Okay, so I hope so you have understood very well what we have to write here, students. Remember that here, see, object is moving with which one? Anyhow the non-uniform velocity. Non-uniform velocity, non-uniform velocity, and acceleration anyhow A equal to dv by dt. It is keep on decreasing, the slope is keep on decreasing. acute angle, but anyhow the slope is keep on decreasing. So here what will happen that here also acceleration will keep on decrease, and it will be the function of time. Which kind of acceleration? Non-uniform acceleration here. Okay, positive but increasing, positive but decreasing here. Is it, students? So remember that here. Okay, and is it clear now? See here, v greater than 0 here now, and anyhow a is greater than 0. Again I'm telling that here velocity is increasing. Here also what is happening? Remember that here v is greater than 0, and a also what is happening? Greater than no, velocity is the positive only, no, and here also what is happening? The velocity is increasing only, no, greater than 0. And what is happening that here also what is happening? The velocity is increasing. Is it? It does not depends whether the increasing or decreasing. It depends also whether positive or negative. Okay, so here velocity positive, acceleration positive, increasing but positive, so velocity increasing. Here also what is happening? That velocity is the positive, acceleration is decreasing but positive anyhow, so velocity will increase. Is it, students? Great. Now let's see here. We'll go for the next one. Here what we are going to see, acceleration time graph we are going to see here. Important. See here, the third kind of graph is the acceleration time graph here. Okay, so see here, first point, very important. Area under 80 graph gives change in velocity, not velocity. What it will give? Keyword, the change in velocity. Very important. Okay, and you know very well, if I write here, see, A equal to dv by dt here. Okay, so what we can write here, see, this dv equal to a dt, put the integration and put the integration. And what this integration of dv will give here? This integration of the dv will give here delta v equal to a into dt. That's why what is this? Change in velocity. Okay, great. Now after that here, remember that here acceleration is the vector quantity. So anyhow, if this area is A1, this area is A2. Okay, so you know very well here, upward area will take here positive, downward area will take here negative. So in this situation, if we want to calculate change in velocity from 0 to, let's take for example t I have taken here, or let's take I have taken here t1. Okay, so remember that here change in velocity at t equal to t1 minus velocity at t equal to 0, upward area positive, downward area negative. Okay, so from which time to which time we are going to calculate change in velocity, that specific areas we have to take. Upward area positive, downward area negative. Is it? Great. Now students, as we know before also, see, the slope of 80 graph can never be infinite at any point, because infinite slope represents infinite jerk, because rate of change of acceleration is called a jerk. That is in a J advanced syllabus, not in our J mains and a NET syllabus. That is not possible practically. So again I am telling that infinite jerk is also not possible. Okay, see the third point, at one time two values of acceleration is not possible. Okay, remember that this also. So I hope so students, all these things are very clear to you. Now we are going to see acceleration time graph. Very limited graph is this one. So see here, first one, acceleration time graph, two cases only we should know that here. Let's take for example here, with the time acceleration is constant, 1, 2, 3. Is it? So here what is happening that here, remember that here object is moving with a uniform acceleration. What we can tell the students, object is moving with a uniform acceleration. Why uniform acceleration? Because the acceleration value is constant. A is a constant, that's why we can tell here the uniform acceleration here. Now A naught value is constant here. That's it. Remember that. Now, and equations of motion, whenever this kind of graph uniform acceleration, equations of motion will be applicable, that you know very well. Is it? Now after that, if we talk about here the second case, maybe let's take for example, it is given the like this, no? This color, no? Pink color, maybe case 2. Maybe it is given here, let's take for example, they are telling here this, let's take this case here, case 3, blue color. Maybe let's take they are giving here this one, green color, case 4. Is it? So in any case is there, or even if we talk about here, let's take for example this yellow color here. Now this is 2 is there, now let's take I have made it here 2 star for example, whether 2 or 2 star anyhow. So any case like this is there, na? So this all represents what? This all represents object is moving with a non-uniform acceleration. What is this here, students? Remember that here, very basic, object is moving with a non-uniform acceleration. Okay, in this situation, equations of motion will not be valid here. Okay, then what will be valid here? Here it will be valid calculus. Which kind of calculation will be? Calculus will be valid like this: v equal to dx by dt, or we can write here a equal to dv by dt, or we can write here v into dv by dx. Now, even in a practical way, we can write v into dv by ds because object can move in x direction, y direction, z direction, but by default we take x. Okay, so that's why we are writing a equal to v into dv by dx here. Is it? So first one, uniform acceleration. Next one, any kind of line is given. This one represents non-uniform acceleration. Calculus will be valid. Here equations of motion will be valid here. Okay, and in a basic way, calculus is valid everywhere, whether uniform acceleration, non-uniform acceleration, calculus is valid everywhere. But in case of non-uniform cases only, in case of non-uniform acceleration only, we use the calculus. But here, what is the need to use calculus when equations of motion is valid? Is it? So remember that here. Now students, if we will talk about here, see, one more kind of graph is there. Let's take for example, velocity position graph is given here. Velocity position graph. So for the velocity position graph, how the things may happen? Remember that here. Let's take for example here, this one. Now at t equal to 0, anyhow velocity is v naught. Okay, and let's take for example, this is the slope. Now let's take alpha, and we are telling that here this slope is m equal to tan alpha. Anyhow it will come here positive. Okay, so remember that here, first thing, from the graph y equal to mx plus c. Y equal to what? Mx plus c. Is it? So what will happen that here, you can use any equation of any way to write the equation of straight line, but anyhow I am using this method. So what will happen that here, we can write here the equation v equal to mx, v equal to mx plus v naught. This is the equation of the line v versus x graph, v equal to mx plus v naught. Okay, so this is the just way, y equal to mx plus c. This is the one way to write the equations of a straight line. Okay, so if we know the equation of straight line, after that if we want to calculate the acceleration, what is the formula? Remember that v into dv by dx. Is it? So what we can write here in this, we should know this dv by dx. So with the help of this graph also we can write dv by dx also. So see here, velocity how much here? Velocity is coming here, remember that here, see, mx plus v naught, is it, into d by dx of what is coming here, mx plus v naught here. Now this is here. So the value of v how much here? Remember that here, mx plus v naught into, and here when you will do here the differentiation, d by dx of mx how much here, m, and differentiation of v naught how much here, 0. Okay, so what it will come here, see, m into mx plus v naught. Now, and you can see very well with the help of velocity position graph how we can calculate the acceleration also, because number of times they ask here the question. Okay, even if sometimes, let's take for example this one you don't want to use and you know only coordinates. Let's take here coordinates. For example, the coordinates are x1 comma v1, and somewhere here the coordinates are x2 comma v2. So in that situation also we can use the equation of straight line. Now just under the extra I am telling you. This is the one way, like y equal to x plus c. This is the another way. What is the equation? Maybe maths you have seen, y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, with the same basic we'll write here the equation for this line. On the vertical axis what is there? Velocity. So we'll write here, see, v minus v1 is equal to, see, v2 minus v1 by x2 minus x1 into x minus x1. Okay, so this also you can write, this also you can use to write the equation of a straight line, and then you can use this formula and you can get the acceleration here. Is it? So this is the velocity position graph. Now next one, for example, if in case it is given here what, they have given acceleration position graph here. Let's take for example now. So here what will happen that here, again I am telling you, see here, let's take for example here a naught, now intersection a naught. Now, and let's take here for example here I have taken for example, let's take beta angle. So what will be the slope? Slope will come here m equal to tan beta. M equal to tan beta. Is it? Now what will happen that here in this situation, what will happen that here, if I write here the equation, so what will be the equation? Remember that here Now, in the same way, y equal to mx plus c. So a equal to, it will become here mx plus a naught. What is coming? A equal to mx plus a naught. What is m? M is the tan beta, is it? Similarly, after that, here what will happen that here, remember that here s, what we know, a equal to v into dv by dx, is it? So what we can write here, see, v into dv is a dx, na? Put the integration, okay? So let's take for example here, we are going to see position. Let's take for example here, x equal to x1, na? And here x1 how much here? 0, na? Generally we are saying x equal to x1 to x2. Here, let's take initial velocity is v1 to v2. So what will happen that here, integration of v dv means v squared by 2 v1 to v2. And here what will happen that here, students? What is the significance of the integration? Area. Okay. So what we have to do here, remember that here, this area we need here. Now this area. Even sometimes if we can calculate the area directly, now we can calculate the area, maybe triangle, maybe trapezium, any kind of shape, we can calculate the area. And if in case we can write the equation of this straight line, then we can integrate also here. Now, so see here, integration what is given here, see, mx plus a naught into dx, where to where? X equal to x1 to x2, is it? If I write just one more step for you, it will become here m integration of x dx means x squared by 2 plus a naught x, is it? And then we can put here the limits here, where to where? x1 to x2, is it, students? So after that, upper limit minus lower limit and all that, when you will do here, na? If I write for you, let's take one for example, again I'm writing it 1 by 2, I can write here v2 square minus v1 square is equal to, here what can I write here? See here, students, here I can write here, see, m by 2 x2 square minus x1 square plus a naught x2 minus x1, is it? I'm just telling you the basics, is it, students? So I hope so all these graphs like position time graph, velocity time graph, acceleration time graph is very, very clear to you, especially the cases. And after that, velocity position graph and acceleration position graph. All these 5 graphs are very, very clear to you. These basics are very important even in 12th also. Okay, students? So I hope so this video is very, very clear to you. Keep studying, keep growing.